Welcome to the O-Scope Wizard. I am Gabe, the O-Scope Wizard. We are running late today because out in the driveway of the Techno Lair, we had a delivery. And the delivery was this giant, huge RV travel trailer. We are going to try some camping. I've never done it before. I don't know if I have any campers in the audience. I know that I have at least one camper in the audience because he's mentioned camping over the weekend. And hopefully we love it as much as he does. We are going in for the travel trailer, so we've got this huge, 30-foot trailer sitting in our driveway that we're gonna set up and hopefully take out on some trips. It's Tuesday, it's Band Shirt Tuesday. I have on a Half Alive shirt. I've worn it before, but it is tie-dye, so it feels like, let's get tie-dye back out there. Let's try it out. I haven't done much tie-dye, and I don't see much tie-dye around. But today, we do have an actual topic. We are going to be testing 1, 2, 3. Can we get automatic speech recognition working on a Raspberry Pi? On the last episode, let's start the timer. We've got to start that timer. If we don't start the timer, we'll never stay on track. And we're already running late, so we better start this timer to keep us on track. So 20 minutes. Let's get into it. I turned off the wrong thing, turned off my Raspberry Pi, and I wanted to turn off the agenda. So here is the Raspberry Pi. Let's get the masks out of the way. Raspberry Pi that we've been using, it's the Raspberry Pi Zero, hooked to, this is the Raspberry Pi Zero. We have a battery in the back, which is really nice. I actually did some debugging of my Raspberry Pi in the driveway this weekend. Having it on a battery is really cool. You just, let's see, it's going to make a liar of me now, but, I disconnect the power plug and boom, it's still running there. We still have lights and that has been awesome. And on the top, we have this ReSpeaker 2 microphone Pi hat from Seed Studio. And this is what is going to be capturing our speech with the microphones, sending that speech to the Raspberry Pi via the I2S port, which we confirmed on the last episode. And I want to see if we can now actually get some of our speech recognition to work. So let's see if we can find it. Right here. Here's what we were working off of originally. It was this article that originally appeared on Hacks4ido, but now Seed Studio has on their blog because it's kind of highlighting using this Seed Studio Pi hat. And this guy first of all, he checked out CMU Sphinx, Caldi, and Jasper, which are 3 different automatic speech recognition engines. And he recommended Mozilla's Deep Speech automatic speech recognition. I don't know anything about speech recognition other than my ears do a very good job of recognizing speech. So that's where my expertise on speech recognitions begins and ends. When it comes to electronic speech recognition, this is something totally new for me. And our problem with this particular article was we have a Raspberry Pi Zero, and I thought that I could just install Deep Speech on my Raspberry Pi Zero, but that proved to be incorrect. It does not work. So I need to, think of a different tack. And let's see, this is what I decided to give a try. So we are going to try PocketSphinx, which actually uses CMU Sphinx, but it is a super lightweight speech and voice recognition engine. It did install on the Raspberry Pi. We do have it working. I did all of these steps, and we could try some stuff today. Thanks for joining. I see you in the chat. Thanks for waiting on me. I'm sorry I was so late. It happens. Life happens. Sometimes we're all at home. We're all stuck at home, and we've been at home for a really long time. And so, sometimes life happens and it throws us curveballs. Let's get into the terminal. So this is my terminal. Look at this. I'm connected to this Raspberry Pi that I'm holding in my hand with the terminal. I want to try, oh, and then it's going to say disconnected. Let me get back over here. Are we connected? Disconnected? Disconnected? What? Why would we be disconnected? Let me see if I can get this thing reconnected. Log out. Yes, let's log out. Let's close this. We're going to close it really quickly, and then we're going to reopen it. Log in. You're going to see a blank screen here for a second. And then boom, we're back in. We're back in like Flynn. We have a connection to a Raspberry Pi. Probably happened when I disconnected it. Big surprise. The first thing I need to do is record a waveform. So I am going to say into this Raspberry Pi, testing 1, 2, 3. This is a microphone test. And then we will see if the speech recognition can print out those words. We are going to try to get that all working. We're going to start with a recording. So I will do a record. I think I can just do a record temp.waveform, and it should do it. Let's see if it'll work. Testing 1, 2, 3. This is a microphone test. Okay, now I should have a waveform called temp.wave. There it is, temp.wave. I even have a waveform called tomp.wave. Let's delete that one. Temp.wave. Can I play that to the speakers? I think I can actually play it to the speakers. So I'm going to bring that waveform over and we'll see if we can hear it. Let me turn my sound way up. Testing 1, 2, 3. This is a microphone test. Okay. Okay, we're testing. It worked. We got testing 1, 2, 3. This is a microphone test. Okay, so that is what we wanted to record, and we recorded it. Let's see what our recording was at. 8 bits unsigned with a rate of 8,000 hertz. So now I want to try to send that waveform to PocketSphinx. So what is it? PocketSphinx continuous. I think it's in file temp.wave. Now there's going to be, it's going to complain, I suspect. Oh no, it just took it right away. Wow, this is working so much better. So when I practiced this before, it worked terrible. Oh, here we go. Here we go. Failed to process temp.wave due to format mismatch. It recorded 8 bits per sample, and PocketSphinx wants 16 bits per sample. So it gets kind of finicky, honestly. Okay, I think I can I do a record dash bit 16 temp.wave? Will it do that? Let's try that. See if we can just do a new command and make it work. No. But you know what I think I can use? I think I can use record. I think so. So this is what I was using. So this is SOX. I installed this program called SOX because just the ALSA, ALSA recording engine was giving me trouble because it was kind of finicky about the channels and rate. So what I can do with SOX is I can tell it that I'm using one channel. Let's see all the things that I need to do. I'm using one channel, and I think I can also tell it the sample rate that I want. Let's look here. If I can find it. I think I can. Oh, here we go. Bits. So I need 16 bits. I need one channel, and I want to, and it looks like 8,000 hertz is perfect. So that needs to be 16 kilohertz because you have to record at twice the rate of the bandwidth that you want to reproduce. There was a guy named Nyquist who told me that. He is a very famous engineer. He's probably more of a mathematician, but let's see. So SOX C1 R 16 kilohertz dash bit 16, and we will send it to temp.wave. And let's see if this works. So it's a one channel, 16 kilosample per second, 16-bit file. Testing 1, 2, 3. This is a microphone test. Okay. We clipped. Decrease the volume. Probably. Let's try it again where I'm a little bit further away from the microphone. That's kind of cool that it tells me that it clipped. When it clips, it could make the, I guess, you know, what I could do is listen to it really quickly and see what it sounds like. So let's bring that file over to my computer and give it a listen. Testing 1, 2, 3. This is a microphone test. Okay, I could understand that. I wonder if our software can understand it. Let's before we just make a new recording, let's send this to PocketSphinx. It needs to see if it can find testing 1, 2, 3. Okay, it says 5 words read. I see that in there. I can hear a little bit of a squeak in the background. What is squeaking? My fan is going bonkers. You hear a squeak. I'm not sure what is squeaking. Something is squeaking. You can't hear it, I don't think. It's the kind of thing that would drive you crazy. Okay, if I was to make any sort of judgment right now, it is that PocketSphinx is taking quite a long time to tell me the words that I said. And this was one of my worries, that it would decode the words that I said into text, but it might take a long time. Okay, it looks like what? Didn't even say what. I said testing 1, 2, 3. This is a test. That doesn't look great. It's also taken a really long time to. Oh, look, this is a microphone test. Okay, so it got some of it. Let's do that all again, but not spit out the log. So this, I think I can do log function. We want to send that to a device called dev null. That means don't do it. So I think I need to do log fn. Clearly, I've been doing some reading off camera to make all of this work. But if you search PocketSphinx on a Raspberry Pi, you will get to this website, and it will at least get you started and installed. And from there, you will need to Google PocketSphinx to try to figure out how to use this thing, because it is not user-friendly. I mean, it's not trying to be user-friendly. It's kind of a scientific project devoted to speech recognition. And yeah, so it is kind of what it is, I suppose. While we wait, we could have played a game. Would you rather? Would you rather? This makes me think that the Raspberry Pi ultimately, one thing that's really cool is this is all happening. I can hold it in my hand and it's doing this processing, and it's like, it's kind of crazy. This battery pack I think the battery pack is the coolest part of the whole project. Honestly, it makes it totally wireless. What? What? So it got testing 1, 2, 3 became what? clearly that messed up. That could be the volume problem, as the recording was warning me that I had clipped my volume. This is taking so long to do. I mean, it did get this as a microphone test, so that's pretty good. But I want to get this thing working from the microphone. So there is actually a command to make that happen. So I can do in mic. So PocketSphinx in mic, and you can send it a flag that says yes. So now what PocketSphinx will do is use the default microphone on the Raspberry Pi as the input, and it will attempt to decode in real time the speech that is coming into that microphone. And I want to do a test where I turn this on and then I just try to talk to the Raspberry Pi and see if the speech will be decoded. Don't know if it will be decoded. This is a tough one. So let's crank it up. We're off and running. I am in a unique situation with this Raspberry Pi and with the fact that it only has one microphone plugged into it. But you can see input overrun, read calls are too rare, non-fatal. It's at least non-fatal, that's good. The Raspberry Pi is not dying. Wait a second. I can literally hear it. I can hear this. Oh man, you know what? Shouldn't be audible? A battery. I can hear it like that little whistle that I was talking about before is the Raspberry. That is so weird. Yeah, I can hear it actually talking to that battery. That is unfortunate. That's a bummer. Also, it's a bummer that the input overrun read calls are too rare. So what does this mean? When I Googled input overrun, read calls are too rare, I think I can selection copied to clipboard. If I go to PocketSphinx, let me see if I can type input overrun. What does it tell me? I will warn you, I did run this before. And the answer right here, here it is, Stack Overflow. Good place to go with your programming questions. If you can take the heat. The heat's gonna be real. They're gonna, whoa, I didn't show you the Google. That's actually probably good. So we're going to Stack Overflow. We're gonna look this up. So this guy had the same problem as me. He had he's got a Raspberry Pi 3, so it's even better than my Raspberry Pi. He is getting the problem where it says input. There we go. Input overrun, read calls are too rare. Input overrun, read calls are too rare. You need to run decode. Let's see. The message says that processing is too slow. So what that meant was my Raspberry Pi running this PocketSphinx software, the Raspberry Pi Zero, a little too slow. A little too slow. It can do the recording and do the decoding somewhat. It's pretty slow, but it can work. So this makes me think that I have a decision to make. I can either maybe record small snippets into like this rolling buffer that we constantly are trying to decode. So maybe we ping pong between buffers. That's actually a strategy that's used a lot of different places to make processing easier on a computer, because a computer can only process data so quickly. So if the data comes in faster than the computer can process it, you have to store it in a buffer, and then the computer can get to the buffer. When the buffer overruns, it means there's no more space to put the data, so the data just gets lost and can cause crashes. But what you could do is you could have a rolling ping pong, so you could have two waveforms constantly going, and anytime sound is detected, it'll start storing that sound into one of the waveforms until it detects maybe a gap that's a certain amount of length. And then it starts processing on that. And then we make a new waveform to capture the next speech. But I don't know how far back the Raspberry Pi would get if we did it that way. I suspect quite a bit back with the Raspberry Pi Zero. So there was another thing that I could try. I mean, there's a bunch of other things we can try. There's a million things I can try. One of the things that I noticed was, I don't know why I didn't go here first, but guess what has a speech recognition package built right into it? If we can make our internets go faster. Our internet's going kind of slow today. I wonder what the, hopefully the stream looks okay. But the ultimate guide to speech recognition with Python. I'm back to Python. Have really liked Python. Before I started these DIY projects, I was no lover of Python. But now I really see the power of it, the fact that it's just got this huge community developing things for it. But one of the things that this Python speech recognition library has is the recognizer class. So installing speech recognition, super easy, super easy. You know, I already did that. Pip install speech recognition. I don't know why I didn't start there. But once you've installed it, you have to pick an interpreter. And this is, oh my gosh. Oh my gosh. Hold on, hold on.
5 minutes remaining.
5 minutes left. 5 minutes left, and we're gonna stick to it. We're gonna stick to it. 5 minutes left. We just set our timer up for the last 5 minutes. We'll get back into it. Once you have installed the speech recognition onto your Python, you have to choose the speech interpreter, which is cool because the recognizer class has all these built-in APIs that it'll use. One of the things that I wanted to do, though, was do something that was offline. The only one of these that is offline, I think, is CMU Sphinx, which is PocketSphinx. So I am going to try using this Python library with PocketSphinx to see if that actually improves the usefulness of the Raspberry Pi. I don't know how it would make it faster to have an overlay layer, but then again, I'm just a dude. I don't understand all the ins and outs of this library. But it does allow me to check out really quickly the Google Web Speech API and the Google Cloud Speech. So I think by default, I think this thing uses out of the gate, yeah, it ships the default API key for the Google Web Speech API. So right out of the gate, once I've installed this Python speech package, it locks into the Google Web Speech API, which I think is cool. So we're up and running. I've installed it. I don't know how to turn it to Sphinx just yet because I don't have a Python program written, but I will have a Python program written by the next episode that kind of hopefully will let us kind of toggle between the Google Web API and then the Sphinx API. But I want to try it really quickly with the Pi Audio microphone input. So it says install Pi Audio, which I've done a bunch of times because that was part of just installing the ReSpeaker. And then I can test the installation by running this command right here, python-m speech_recognition. And it will show me a moment of silence, the minimum energy threshold, which is going to be our, I assume, our noise gate, which is really cool because it, like, right out of the gate, it's right from the beginning, it's going to have a noise gate, which is a level that kind of starts the recognizer. So if noise is happening, but it's not loud enough, then it won't trip the noise gate. I actually use a noise gate with my microphone. So when I get quiet, the noise disappears in the recording. Even though there's still background noise happening in this room, there's a noise gate that only trips when I talk or there's a noise coming through the speakers. So let's just try this command really quickly and see how well the Google Web API works. So the PocketSphinx wasn't able to get testing 1, 2, 3, but it was able to determine that this is a microphone test. Let's see how long I let this run. Get it way back here. Let's see, whoop, right there. So it said, what? That's what it got for testing 1, 2, 3. Oh, let's see if we can, oh, let's change pictures so you can see what I'm talking about. The PocketSphinx, when we ran it on our recorded, it said, what? This is a microphone test. Now I want to try it with the Google Web API. So I'm going to paste that command in there, Python-m speech_recognition, and I'm going to talk to my Raspberry Pi. No module. Whoa. Hold on. Let's do Python 3. I'm using Python 3. There we go. Testing 1, 2, 3. This is a microphone test. Okay. You said testing 1, 2, 3. This is a microphone test. That's really fast, though. That is pretty fast, and it's using the web API. That's really fast. That is pretty fast. It's using the, now it's just getting better. Now I feel like I'm in the Matrix. I'm impressed with how fast it's able to go. It's actually able to go much faster by capturing the data, sending it to the cloud, having the cloud operate on it, and then sending the data back to the Raspberry Pi. Oh my gosh. Let's see if it gets all that. It's, oh my goodness, it's crazy how well that works. But I really want to do it without the internet connection. This is a quandary that I have, and everyone will have when they're doing a project. They have to decide what are the trade-offs they're willing to make. Do they want to change the direction of their project if it's not working properly? I mean, if it's not working properly, I feel like you should change the direction of your project. So PocketSphinx wasn't working great because it's so slow on the Raspberry Pi Zero. I bought, spoiler alert, I bought a Raspberry Pi 4 that we could test out. Let's see if it'll show. So there's my Raspberry Pi 4. So I have a Raspberry Pi 4. Get back to me. That we could try. So that might work with deep speech from Mozilla. It should work with deep speech, in fact. So we have a couple of things we can try. Make a Python program that uses some different speech recognition engines. The Google Web API is super fast. Can it use PocketSphinx on the Raspberry Pi Zero? Or do we need to up our computing power and use the Raspberry Pi 4 instead of the Raspberry Pi Zero for real-time automatic speech recognition? I don't know. It's a question that we're going to ask. I don't know how many people compare speech recognition engines in the wild. I feel like they just use whatever's there. We're close though. Our microphone's working. Our Raspberry Pi is working. Our battery's working great. I mean, I'm able to hold the Raspberry Pi. It is disturbingly loud. That's not an awesome sign with that battery's long-term life, but it is working right now. And I don't know all the nerds in the world, so please share this with a nerd in your life. I would love to meet them. Join me again on Baby Friday, where we will explore some of the new directions for our project. New Python code, new Raspberry Pi, lots of new. See you then. Bye, guys.